let's jump into the topic. So I was sitting down and really thinking how I would like to bring up the story of since every time you have to tell a little bit the same story. So I was really thinking about this guy when I was trying to think how the hell to tell the guys where these robots are today. And it gave me a remembrance of beyond or before 2007 when Jobs was about to introduce the first iPhone, and probably at that time nobody has thought of how can you combine these few things into one completely new device. And this here is a perfect example of just combining that. So what I think robots are doing today, they're a little bit like iPhones. They are combining so many different things from the world around us that we already know into sort of very new mixtures that some of them might not even exist for us today. So that's why it's a super exciting field to be in at the moment, and I think we'll be seeing a lot of iPhones coming in. But before we jump into a detail, let's do a quick run from the start, or from a little bit earlier in the previous decade and the previous century. So we as humans have been really good at imagining robots, especially humanoid-looking robots, as you can see from the beginning of 20th century. Though actually, what really happened during the whole century, we didn't push very much a lot until the last decades, where different research groups started playing around with smaller robots than these first industrial robots. Probably everybody knows very well how the sort of new uh, industrial revolution rolled out with more and more companies introducing these big industrial robots. And then smaller fields started emerging, especially in Japan and other labs where companies started working on smaller versions, especially the ones which could walk, or the ones which could drive on the floor, and similar. So once again, we look a little bit at thousands of years ago, and we can clearly say that we as humans and the creators of the robots, first of all, have been perfecting the tool, because that's a sort of key thing that we are expecting out of any robot system, and that was always a thought behind why we created it in the beginning. And if we could sort of capture the whole, I don't want to call it the last era, or still an ongoing era, so we should really be thinking about the robots in this form of that the robots really are tools. They're not people, and they should really be seen as instruments which should not be having rights, but rather should be having limits. And let's see how these thoughts really affect of how we tell the story further. So in order to grasp a little bit where the world is today, I always like to play around a little bit with numbers and then show what kind of sort of population or numbers of robots we have. And only in the last good decade, I think we can say that the sort of industrial robots, or the boring robots as we call them in the factories, have actually gone out of the picture, and more of homemade robots or personal robots has been kicking in. And just some numbers that I happen to collect here for the 2020. Not all of them are still final, but just to get a good feeling. It seems that for the last number of years, the sort of industry trend is so that there is around 3 to 4 million of these robotic arms all over globally. There is some good 300,000 that we're shipping every year. Of course, then we're taking some of them out. There are new ones are keeping in, but that's more or less the population we have. There is also a new field catching up, which is these mobile robots. You can see a picture here of these driving platforms. Since thanks to COVID and many other areas, there is a lot of internet sales booming, and there is a lot of new warehouses built. So this has been the hottest field of robotics in 2020. And and here as an example, also we should just take a small peek that medical robots and all these super futuristic things that we like to see, like exoskeleton, is still a very minor friction in all of the robotic population. What is interesting to the contrast is actually the personal robots have occupied in terms of population in tens of times. And we can really see that our favorite vacuum cleaners, pool cleaners, lawn movers, or any other type of personal service robots have really exploded. And this only more or less happened in the last 10 years, where it really started surpassing the sort of professional robotics area. And this brings, of course, these robots out of the cages, as people used to say, out of these industrial environments. They're bringing them into our most sacred places, like home, like bed, like, you know, bringing them close to our children's, or even surgery or doctor rooms. And this is, of course, affecting our everyday life, and so that we should really think of how this relationship might work and could work out. What is unfortunate to say is that still the biggest majority of the market is consisting out of military and industrial robots, and then that affects, of course, many other areas. But hopefully this number will start evening out over the years. But still, this is a little bit frightening, at least for me, still. This is just a small cover for you to see how the industrial, or these fenced robots, as we used to call, have actually been adopted over the last 10 years, and how they grew.
Quindi,
and sorry?
sono tecniche che ti fanno fare un salto.
Sorry, I didn't get you.
I think that wasn't anything to get to. It was not in English. I will identify the person and.
Okay. I thought that maybe this was a question. Okay, but then just to get back to this, so as I mentioned very quickly on the industrial robots, it seems that this adoption rate is plateauing. And what, let's say, different types of experts say is that probably a certain type of work areas have really been already maximized, especially in the factories, where we are not going to see a very big jump in certain types of these, a little bit, I would call, old school robots. The ones that are picking, the ones that are placing, maybe they're painting something, lifting pieces. So these sort of mechanical robots, which had replaced a lot of mechanical or hard labor work. So these sort of installations seems to be plateauing. And what is entering the area is something that we call robots, which are needed to have a better interaction with people. So in order we can look into these interactions, let's look at the very nice degree of interaction chart here. And this is a key for understanding any type of robotic to human interaction. And I call it 5 levels of collaboration chart. As you can see on the top left corner, where we start is we have a cell, or we can call it the old school type of robot, which is in no way capable of knowing that there is a person. So think of it as a very dumb system which is just working there. And if you step into that area, or if you sort of get over the fence, the robot will most probably hit you, and might hit you really bad. So this is the old type of the system. The second level of collaboration is the types of systems that is still very much popular today. So that the robots are not using a lot of fences, but they're using what would be called laser curtains. So there's sort of small laser systems that is protecting for you. If you step into a certain area, the robot system will stop working, and that is called a coexistence. So that if the system is dangerous, the system is able to stop itself before a human can get next to it. So and out of this, there has been a very new type of development, the third level, which is called the shared workspace. This, or sequential collaboration, where the robot with the human being, they are collaborating, but they're doing operations one after another. So if you would think, you would push something, get away, the robot would actually do his part, and then maybe push it back to you, and then you do your part. And this way you don't step on each other's shoes, as to say. The fourth level of collaboration is something where everybody wants to be today and step into this very close, is something we call a shared workspace, where both players can be in motion. So the best example of it could be if there is a robot driving on the floor and you're walking towards him, that the robot will not just hit you, but the robot is seeing you, and he will try to calculate that trajectory and drive you around. Or if he sees that you're too close, he will actually stop. and a cooperation where a robot can work together with a human, meaning that if you're both working on the same piece of something, let's say you're assembling something, then the robot can work together with you and be able to sort of coordinate your movements. And of course, the area where everybody wants to be is something we would call a completely adaptive system, where we can all work in real time. So it means that the robot actually doesn't know what you might do, but the robot is able to sort of a little bit predict and be able to respond in real time to your movements and to your changes. This, as I say, just for you to clarify, this is not something which is only applicable to industrial robots. This is very much applicable to any type of the robot system. And what we see today, I will quickly run through some interfacing techniques. So as you remember, these 5 levels, the first generation fenced, and the ones which we sort of want to see very much in the future are very close by in real time. So we step a little bit back again in history and look at these computer screens and the robot control boxes. As you can see, they already had some joystick here in 59 to control the first robot arm and its movements. We have not gone very far away. This is a Danish success story, Universal Robots, the so-called collaborative robot company. And they still have more or less the same interfaces, which are very much engineer oriented or technology person driven, though they are really, really much better than any other type of systems. They're still quite hard to program and communicate with it and interface with it. And the area which is really kicking in, which is super interesting for everybody, is an area where you can collaborate with a robot by your natural ways of collaborating. It's by either gesturing, by using your voice, by using certain type of micro signaling. And here you can see a picture where we simply see a small set, which you would really like to be able to show the robot that, hey, take this piece here, put it with this piece, take this piece here, put it with this piece. And then the robot would just, sort of read your gestures and read your maybe even small voice commands and just do the assembly work, because it's not that hard, right? And here we will stop shortly. I will drop you in first. I will drop you in the first video link, which you can see here. In the chat. So if everyone would just jump in very quickly and take the link from the chat, I will actually also play it here in the background. It's a 3-minute video, but it's a friend of mine in Germany who has been working with exactly this new type of interaction system. That maybe I will play it here in my slideshow. Well, everybody. Well, yeah, in the background, while everybody opens it on their screens. And that was exactly the goal of such a system, is to be able to not use any sort of old school type of programming interfaces that is engineers only, but to actually be able with a robot to, first of all, control it in certain modes, bring it to certain modes, give it certain directions, and then actually do a common task together by assembling a piece of let's say, as doing a common assembly task together. So that is a mix of a very simple system, which is also mixed, as you can see, with Microsoft Surface, but it's also using a Kinect technology to track human motions, so that the robot is understanding where the person is standing and what he doing. And as you can see, also the table is used for the for the projection of certain assembly steps, that it's easier for the worker. He doesn't have to sort of know or remember everything. He can just do the task that he's needed to do with the robot. It's actually deliver his assembly work. And this way, not worry about, you know, how the hell do I move the robot? How do I program it? How do I make sure that, you know, the robot has followed, or that the robot really understood it, and things like that. So the system is also communicating back over the screen to the human if it has a certain state, like take part, or where it is at the moment. And of course, lets the user know when the task is finished, and when the user can start another one. As you can see, gesture control only. So this was the sort of third generation, if you remember the 5 levels of collaborations. 5 levels of collaboration. This was our desired level where we can really work with the robot real time. So this is this was really not the place where we were standing behind the fence, or we were unable to interfere with the robot. This was here where we were more or less in real time, absolutely collaborating with the robot. And there is a lot of companies experimenting with this in the industry, so that actually the people who are non-technical could be entering certain types of jobs and actually adding value by being more creative, by doing their parts of the job without having to think about the whole assembly instructions, you know, what kind of pieces this has to go, you know, how do I control the robot, how do I make this safe, and many other questions that a person really doesn't need to know in order he could perform his functions. Now, what is also coming with these interfaces, as you remember, we looked at some of these old school screens and joysticks and whatever, is this is a sort of the new type of technology we want to see in more robots, and that is being experimented right now by company Neuralink. Probably everybody has heard about another crazy project from Elon Musk. So the brain-computer interfaces will also be the next step to having better interfacing with certain robotic systems, at least by being able to give certain types of commands, being able to control them remotely, and do some functions for which we now, for example, need hands, programming interfaces, and many others. So we should really count that in as a very desired interface and command control center of also the future. Now, probably the hottest topic of the days here is something that we would call social robots, or as one very nice researcher called, robots which are intentionally designed to invoke feelings inside us. And here we really need, when we think about these social systems, we really need to think about this, the systems that resemble us very much, and why we feel with them certain connection or certain feelings is also a big research field, both now in psychology and including behavioral psychology, also including children education and many others. And let's touch on a few areas where these social robots are really having a big effect already. So the social robots that teach, or they participate in our everyday tasks is types of systems that certain type of teachers, pediatricians, special care need doctors, let's say for children here, for as an example for autism, that can employ in their tasks and actually have these robots collaborating with children. And by this collaboration, I really mean a very broad way of collaborating, because children are interacting with it as one-to-one. Sometimes they mimic collaboration as if they would be collaborating with a specialist, with their friends. And that's why it's also important what kind of information the robot is bringing to them. And Milo here was been the first type of the system. It has a number of facial expressions that it can do, which are very important for children to react and understand certain emotions. It also had a wide variety of movements available, so that it's combined also can have the full sort of interaction, giving the feeling that you are communicating with somebody who is very much alive like you. And of course, a very well made sound system, which proved crucial, for the content. Now this will be the second video, so I will just quickly drop in the link here about this Milo robot, and then we won't have to look at any more links. So for everybody, I'm just dropping this link here, and everybody can take here a quick minute and just look at it. I will also play it here on the screen, so that we are sort of in sync. Yeah. So hopefully everybody's more or less in sync, and the video has managed to end, and we can switch to the next sort of small robot that we are going to touch here. So as we just saw from the Milo case, it's a fantastic therapy robot, which is really doing a tremendous help for therapeutes who are working with autistic children and people, and assisting them on various range of tasks, from facial expression understanding to certain repeatable exercises they do, combining, as you saw, with video and text material. So it's very powerful. There's also a subset of these things which we can do with normal children, and one of the platforms that is really very popular right now for smaller children, or we would call maybe early classes in the school, is a platform called Sphero. Probably some of you have already seen this small ball, which fits in the hand, and you can use a mobile phone to drive it around. And there has even been a Star Wars version of it. So probably, if you don't know, your kids know, or at least you have seen it in the neighborhood. But what you can do with it, because it's a small ball which is driving around on the floor, and you can control with it. So we did an experiment a long while ago. We actually built an educational platform on an iPad, where two children would sit one in front of another one and actually play with it, have a competition sort of on different math tasks. And as you can see here, for example, the children have to calculate the area, or they have to sort of draw a certain type of geometrical shape, and the first ones that actually do it, or the first ones that calculate correctly, actually get a score. So this is also a competition, but you can also play, the children can also play it on their own, and actually this way get a very different level of immersion. What is important to emphasize here, that both in an example before with Amila and this Sphero here, it's not software engineers. It's not engineers who are sort of pushing the boundaries. The technology people have created the robots because there was a need and somebody helped them. But it's actually the people who are on the ground. It's the teachers, the therapists, the parents, and let's say a school manager or some sort of platform with people who are interested in this, are creating the content. And this part is also in this collaboration very, very important, because technology people will never know so much about human psychology like a certain type of specialist would do. In this case, we had a fantastic Danish school in collaboration with us, who had tons of curriculums. They really saw that the children already liked, and they wanted just to adapt that to this platform. So this is already a very powerful sort of interdisciplinary match that different levels of specialists can do without having a background in a lot of engineering. Now, we also already saw in one video before the very popular now robot, which can do pre-recorded, which can play pre-recorded sounds, whichever language. It can do certain dialogues combined with certain movements. So sort of you can pre-program it on a sort of easy to understand user interface to do some social interactions. And it has been widely popular also, and adapted in many conferences and in many playful tasks. Now, a very interesting project has been born in the US quite some time ago. It was called Jibo, and that was a robot which was supposed to be your companion at home, which was supposed to be a sort of social robot for your kitchen. A robot which is standing next to you. You could call him and say, what's happening on my calendar, sort of what's the recipe for this and that. So sort of think of Siri, but with a physical presence. And physical presence here, of course, it gives a very different flavor, because it's way more fun and way more intuitive for us to interact with something that has a physical presence than just Siri, which is only responding to you in voice and is a sort of semi-virtual thing. Unfortunately, this project was not a very big success, and probably the company is trying something else now. Now, the social robots that really can come very close to us, and this also affects different types of life, where I mentioned in the beginning, the robots are really getting into different types of areas. This is a very interesting new robotic company which is helping people sleep better, and a robot which can travel with you in your suitcase, and is a sleeping robot which has certain sort of vibration movements, so that it calms you down. It has certain feel that it does. So it's sort of, as I remember, it also probably has some temperature. So it sort of gives you a sort of presence, a visualized presence of somebody close to you, which somehow naturally soothes your body and then calms you down, so that you feel much more relaxed, and then this way can be positively affected. And a very popular robotic solution that was in the beginning very much adapted in Japan, and actually came out quite some years ago. I think originally it was adopted in the 90s, the Peri Robot, which was, the idea was to substitute the live animal therapy, because it was a very well-known field of therapy, especially for people with dementia. It really helped them reduce certain dementia progress, really give them back certain functions, because they started caring about something. And the Peri Robot was so widely accepted, and still is, that it was called, one of the best therapeutic solutions ever. And it just does simple basic operations, but it sort of mimics once again the very close collaboration between a human and an animal. Now, of course, the social robots can go even further if you combine them or give them a little bit more physical power. And there is a new field of these social care robots that are coming in, especially Japan is very well to adapt that because of their very much aging population. But Europe already has a number of startups in this area too. And here is a very nice example of a sort of, once again, animal look-alike friend, very positive, who is taking care of a patient who has an injury and is unable to work for a certain reason, or is having problems because of an aging issues. So it's once again, very social, but helping out with physical tasks. Now, the question that we should be asking at this stage, when we see more and more robots looking either mimicking us or having similarity to us, we should be, asking a question: why do we keep on creating robots that look a little bit like us? And this is called anthropomorphizing, or creating similarities in systems that resemble us. And this, of course, plays with us in a way that we start responding to these machines on the social cues that for us are sort of, in our brains, are intended to be only to respond to live human beings, or to live animals, or to certain life situations. That's why we start ending up in certain situations which are strange to us. And sometimes this engaging technology can really make us be manipulated in some ways that we have not foreseen. And we have probably all of us seen the video where a very well-known company, Boston Dynamics, has had a dog walking around, and there has been some people have been trying to kick it. And there has been all the internet crying about how this robot will come back one day and then really has its avenging day and then wipe out all the humanity. It's simply because our brains are being manipulated this way, and we are being tricked in having emotions for something that is a tool. And this sort of our ability to once again anthropomorphize or give personality to things is really sort of, in one way, it's giving us a lot of perception and ability to perceive and sort of foresee, but in the other way, it's also keeping us in this manipulative state. So we should also try to be a little bit aware of this. Now, by touching robots, especially when they're being, when they're coming so close into our life, we also have to think very much about topics like ethics and privacy. Now, here I want to tell a little bit shortly a few stories. not necessarily all of you has seen this Roomba problem case, as I would call it, but Roomba really had a very big problem some years ago. Roomba is these vacuum cleaners. They had an issue some years ago because what they have been doing when the robots have been driving around in your apartment, they have been collecting data on, for example, how big your apartment was, in what kind of things you have been hitting, the robot has been hitting, what kind of materials more or less it has been collecting, so that people, so they have actually been collecting a lot of privacy data about you as the user. Of course, they have not been, intending to publicize it, but the goal was to understand who was the users of the product. Of course, it was a huge privacy leak in the end, and people have been really annoyed that the company have been collecting so much private data about their apartments and then some other things. So this is once again, by letting the robots in, we have to think of what kind of third eyes, as to say, they're bringing in into our lives. And here is also the case with, if you could think about also the robots, which are very much on the rise and is going to probably be the most popular social robots, is sex robots. So now imagine what kind of sort of analytical data you could collect if the robot is able to see, if the robot is able to have some sensory input written down and then transmit it all to server data. You would have a lot of privacy data. Ethics also comes next to it. We will not touch today a lot on the military robotics. It's a separate topic. But for example, there is a huge discussion happening in the world right now that there should be never a chance to let any country have autonomous military drones. There should always be a person who is making a decision when to kill or not, so that the systems don't become autonomous. And the autonomous killing machines is a huge disaster for the whole planet. So as we see we're traveling certain directions and letting robots be in certain places, we should also think how we can regulate that, how we can once again encapsulate them in such a way that their behavior is predictable and still pre-programmable. That's why an idea that I've been suggesting on the way that we should treat robots more like tools and not like live beings is still key. Now, some key trends that we have both discussed today, and also for you to think a little bit when you want to get something out and think a little bit maybe about this topic later, is, as we mentioned, we're moving from these pre-programmed actions to the robots, which will be more collaborative, and you will be able to interact with them more and more. Now you will be instructing robots just like you're instructing your Amazon Echo or Siri, more with voice articulation or microsignaling. Microsignaling, by the way, is a very interesting new field which is emerging from autonomous driving. And for example, when a person is stepping in the street, there is an action that every person is doing to the driver. When you're stepping on the street, of course, if you're not sleeping or just hallucinating, but what you do before stepping on the street, you try to look at the cars. And when you see a car coming, you sort of try to look to the driver's eyes, where you sort of try to signal that, hey, I see you, do you see me? So there's a lot of these micro signaling operations that is being analyzed now and is being actually put into different types of robotic systems, which are very contextual, but could be very helpful. Content as itself is also key, because as we saw in now robots, where you need a lot of language translations, in the sphere of education robots, all of this is being driven by non-technical people, but by their field professionals. Now, of course, investigating the human psychology and its behavior while in contact with robotic systems is going to be a key field. European Union is going to spend a lot of money on this, especially to trace different types of behaviors and effects on children, especially on people who are having certain problems with communicating with robots and whatsoever. So it's going to be even more studied and regulated. So there's going to be a lot of happening there. Now, simplifying robot programming. This is a benefit about what I always like to say with more robots coming into our lives. I simply think that by letting certain parts be occupied by robots, we will simply be able to let more non-technical people gain much more interesting jobs. And as we saw in the factory example previously, if you would need an engineering degree to go and work with a certain robotic system just to assemble something, this really, sort of keeps you out of the employment field. Now, this is going to change because the robot is able to understand human gestures. It's pre-programmed so that you're able to do some tasks where you don't need to have technical understanding and you're just able to complete the work. This should open a lot of new work possibilities for people that previously could not enter it. This is my favorite example of the day. Sorry for the long text, but I was thinking just, how this very close future will be like when you're a kid running around in your home will be having at home maybe 3-5 robots. And he will, of course, be having his favorite robot, which is able to do certain things like walking and grasping something, and will be able to get some commands from the kid in vocalized, and will be having some sensors, eyes, which can look at something. And where a kid simply, draws an apple by his, shaky little hand and then shows this to the robot, this apple, and the robot has never seen this apple before, but is able to understand that the kid is showing something that looks like an apple, will be able to walk down to the kitchen or wherever it's being sent and actually look for an object that is similar to that and bring this to the kid. Then trust me, the kid will be having a friend of his life because he will be understanding the kid just like the other kid would. That would be the first time where this interaction will really be brought to a human level, like even if it's for a brief second when a small kid can communicate with a small robot. So when does a tool become a being? This is my probably most repeated thing for the day, but I really, really hope that we will never call the robot a being, and I really, really hope that we will understand ourselves and our nature and will keep the robots as part of the machines or part of the tool section in our life and really won't get lost very much in it. So maybe shortly, but that would be short story. So thank you, and maybe some questions now.